Welcome back. I am very happy to inform you, just in case you haven't noticed, that we have come to the end of one of the longest chapters in A-level mathematics, differentiation. And so I thought, we have done so many things in differentiation. I need to do some questions just to go over what all we have discussed, just to help you revise. Yeah. And of course, I'm not going to give any handout on these. I'm just taking some various questions. You can find questions like this in any mixed exercises or miscellaneous exercises at the end of each of the chapters on differentiation. So I'll just do some questions and then. So I've written two questions now. Oh, by the way, my name is MISCELLANEOUS. I'm a maths teacher who has taught maths for over 50 years. And at the moment, I'm just going over various topics in pure maths that are included in the A-level maths syllabus across the board in UK. And of course, the grade 12 and maybe freshman and a bit of sophomore courses in credit courses in mathematics in American and Canadian universities, or grade 12 and first year university in Australia, the year 12 and first year BSc, second year BSc, first year B of the Indian syllabus, or the grade 12 and the first year university and polytechnic syllabus in maths for Fiji. In other words, even though I call it as A-level, it's useful to any of the students in any of the areas I mentioned. Right, coming back to this now. Find from first principles the derivative of f of x equal to 6x squared minus 4. Please understand, you do first principles only if they ask you. Otherwise, you got your formula sheet and you just use them. So we use this formula f of x plus h minus f of x divided by h, taking the limit as h tends to 0, or like the way people in India would do it, y is equal to that delta y by delta x, a limit as delta x tends to 0. I'll stick to that. So what is f of x plus h? Oh no, it's not 6x squared minus 4. It is x cube minus 4x. I'm sorry. X cube minus 4x. So f of x plus h will be x plus h whole cube minus 4 times x plus h. Let's expand this. Will be x cube plus 3x squared h plus 3xh squared plus h cube. For those who don't know this, either you can multiply, which I think would not be a nice thing to see from an A-level math student, but we'll accept it. Maths is maths, so it's perfectly alright. Or you can use binomial theorem. Or if you know this, I think our students in India and Kenya would know this, or perhaps you in Fiji, I'm not too sure, they will know it like this. Minus 4x minus 4h. Then find f of x plus h minus f of x. Would be this minus that x cube and x cube will cancel, minus 4x and minus 4x will cancel. I'm left with 3x squared h plus 3xh squared plus h cube minus 4h. I divide this by h, so I divide that by h, that by h, that by h, that by h. What do I get? I get 3x squared plus 3xh plus h squared minus 4. So dy by dx will be, oh, my pen is giving up, limit h tending to 0 of 3x squared plus 3xh plus h squared minus 4. Remember, h can never be 0. But h is so small that for all practical purposes, you can assume h to be 0. It is so small you can ignore it. So therefore, that will be 3x squared minus 4. which you would know even otherwise. When you differentiate x cubed minus 4x, you get 3x squared minus 4. Yeah. As usual, I forgot to turn on my stopwatch. So I assume I have taken about 4 minutes, 5 minutes to do this. Okay. The next question is pretty interesting. It's smudges, but that doesn't matter. Let's see if I can rub it off better. Oops, that looks bad. So now I think I'll be able to clean it better. Sorry about it. At least as it is, my handwriting is wonderful. And if over and above that there are smudges, you can hardly see it. That's how I had to do this. Hope you don't mind. Well, generally, even though the same formula works, it is preferable to use a 2h interval for trigonometric functions. Meaning, for trigonometric functions, this is what I will use. So your f of x is cos 3x. I need to show that the derivative is minus 3 sine 3x. Remember onion rule? Cos gives you minus sine, 3x gives you 3. So minus 3 sine 3x. But they don't want the answer, they want the method. First principles. So, what is f of x plus h? I'll put the cos of, can I say 3x plus 3h? What is f of x minus h? Cos of 3x minus 3h. Now, there are two ways of doing this. I can do cos a minus cos b is minus 2 sine a plus b over 2 sine a minus b over 2. You remember the sum to product formula which I have taught you. But, you may not remember, then very easy. This is cos 3x, cos 3h minus sine 3x, sine 3h. This is cos 3x, cos 3h plus sine 3x, sine 3h. Agreed? So what is f of x plus h minus f of x minus h over 2h? Will be, I need to subtract. When you subtract, these two cancel. I get minus 2 sine 3x sine 3h over 2h. Yeah? Remember, I proved this formula for you. Limit of theta tending to 0, sine theta by theta is 1. If you have sine theta, I need theta. If I have sine 2 theta, I need 2 theta. If I have sine donkey, I need a donkey. I have sine 3h. So I need a 3h. So what I'll do is, I cancel this. Can I write this as minus 3 sine 3x times sine 3h over 3h. Now, f dash of x will be limit h tending to 0 minus 3 sine 3x times limit h tending to 0 sine 3h over 3h. There is no h here, so it is minus 3 sine 3x. Sine theta by theta, remember, you can't put h as 0 because it's sine 0 by 0. Yeah? So therefore, but for all practical purposes, sine 3h and 3h are almost equal, so the ratio is almost 1. So, in fact, if you want, I can put 3h tending to 0, it wouldn't make a difference, times 1. So, the answer is minus 3 sine 3x, which you know is the correct answer. Very good. Took only 4 minutes. Not bad. So, now, that was how I showed you in the beginning when I started differentiation, how to differentiate using first principles. Now I'm not bothered about that. We now know all the derivatives, so assume you know the formula for differentiation. So this question 2 says, show that the function 32x squared minus x power 4 is increasing. Shall I do it there? Because I need to sketch the curve. We'll do it here, doesn't matter. I will split the board into two. I hope you're able to see here. I'm going to the corner so that you can see here, yeah? Alright? Okay. So, y equal to 32x squared minus x power 4. And this I told you I'm not going to teach you, but I took an example to go over. Increasing function, that means the graph is going up. If the graph is going up, that means the tangent, if you draw the tangent, it will have a positive gradient. But what's the gradient of the tangent? dy by dx. So if the graph is increasing as x increases, then the gradient of the curve is positive. That means dy by dx is greater than 0. So let's find dy by dx is 64x minus 4x cubed, or I can remove 4x times 16 minus x squared, greater than 0. Remember I told you we cannot do differentiation unless I cover algebra, trigonometry, coordinate geometry, because you need all the techniques, right? Now we need mechanics, calculus is almost over. We're now looking at algebra. How do you solve an inequality? You find the critical values. So 4x times 16 minus x squared equal to 0. So we get x equal to 0. X squared equal to 16 gives me x equal to 4, x equal to minus 4. Yeah? Can I write this as 4x times 4 minus x times 4 plus x? Draw a number line. Mark the critical values, minus 4, 0 and 4. This also I taught you. Take a value, check that there is no perfect square anywhere here. This is not a perfect square. It's a difference of two squares. It's not a plus b whole squared. Okay? See, if you don't have it, pick any value anywhere. So, I take a value somewhere here. Let's say x is 1. If x is 1, what is this? That's positive, that's positive, that's positive. Yeah? So, therefore, the graph is positive. Automatically, you see, the number line has been divided into 4 parts. So, the pattern is always plus, minus, plus, minus. So, therefore, with x less than minus 4, gradient positive, meaning increasing. Similarly, between 0 and 4, so 0 less than x less than 4, it is increasing function. So whenever you are asked to find an increasing function, find dy by dx, put it as greater than 0 and solve the inequality. So we know now, and at the same time do you realize the critical points are where your stationary points. When x is 0, y is 0. When x is 4, what is y? 4 squared is 16, 16 times 32 is 512, 16, 4 power 4 is 256. So it is plus 256. And then when x is minus 4, y is still plus 256, right? So those are the stationary points. Now we need to decide, and what are the roots, by the way? When y is 0, 32x squared minus x power 4 is 0. So x squared times 32 minus x squared is 0. I get x squared equal to 0, x equal to plus root 32, x equal to minus root 32, which is 4 root 2, minus 4 root 2. X squared equal to 0, there are two roots. That means x-axis is going to be a tangent at that point. So 0, 0 is a stationary value. Yeah? Now, let us put all that information on this graph. I got minus 4, minus 4 root 2, minus 4 root 2, 0, and then minus 4 and plus 256, 0, 0, and then 4 and 256, and then 4 root 2 and 0. Between less than minus 4, in other words, if you approach from negative infinity to minus 4, the graph is increasing, so that has to be a maximum point. Between minus 4 and 0, the graph is decreasing. Between 0 and 4, the graph is increasing. More than 4, the graph is decreasing. See, you don't even have to find the maximum, minimum points. You're able to draw the graph. So that point is minus 4, 256 is the maximum. 4, 256 is the minimum. I'm sorry, both are maximum. 0, 0 is the minimum. That is your graph of y equal to f of x. So indirectly you have gone through maximum, minimum points, increasing, decreasing functions, solving inequalities, finding points where the curve cuts the x-axis, and drawing the graph. You see, one question in differentiation can include all that information which you might require. So that has taken about 15 minutes. So I think I should stop at that. Or what I'll do is, you won't know, I will write 2 more questions and then I will solve them, okay? I have now written the next question. Let me read it for you. You are given that y equal to cos 2x plus 1 over 1 minus cos 2x. You are supposed to show that. And you can see t equal to tan x. So blindly, of course, you can always do u over v and then expand it. Then remember, you'll have 1 minus cos 2x whole squared, and then 1 minus cos 2x times minus 2 sin 2x plus 1 plus cos 2x times minus 2 sin 2x. You open the brackets, then you simplify, try to bring in tan x using double angles. Yeah, you can do everything. But I always tell you, while that thing works, always try to use the God-given gift. Meaning, I want a single x, I have a double x. Convert double x to single x initially, so life becomes easier. So let's look at that. Y equal to 1 plus cos 2x over 1 minus cos 2x. If you go through, remember I had told you to make a list of trigonometric formulae, and I said we're going to use this in integration. Well, we're now going to use it in differentiation instead of integration. That will be 2 cos squared x over 2 sin squared x. Because cos 2x is 2 cos squared x minus 1. 1 and minus 1 will cancel. Cos 2x is 1 minus 2 sin squared x. Because otherwise, you might say, sir, why don't you write cos squared there as well? Then I'm going to have 2 minus 2 cos squared x. What's the use? Then you say 2 times 1 minus cos squared x, 2 times sin squared x. So why do that when you can do it directly? So y equal to cot squared x. Life becomes much easier now. No quotient rule, no product rule. You use chain rule or onion rule. I'll write this as cot x the whole square. So what's dy by dx? Dy by dx is anything squared gives you 2 times the same thing, and cot gives you minus cosec squared x. Yeah, very good. But then I need tan. That means, look, cosec can be converted to sine. To bring a tan from sine will involve a cos. Whereas, again, your ability to think in terms of trigonometric identities, can you write it as minus 2 cot x times 1 plus cot squared x? Because cosec squared is 1 plus cot squared. Now, I have everything in terms of cot, which is the same as everything in terms of tan. So this is minus 2 times cot x plus cot cube x, which is minus 2 times 1 over tan x plus 1 over tan cube x. You see how life is easy now? So that is minus 2 times 1 over t plus 1 over t cube. Take t cube as LCM, I get t squared plus 1 shown. Imagine if you didn't use this. That's the reason why I took this question, just to show you how to think a bit outside the box. If you didn't use this, you'd get into a big mess trying to use u over v there. Then using trigonometric identities, then you say cos 2x is 2t over 1 plus t squared, and then simplifying, you'll ultimately come to the same answer. But that takes much longer. So initially, if you think for a bit, life becomes easier, okay? Good. So that's one lesson done. Another 2 lessons at least, or 3 lessons, I'll go over various types of questions. So I will see you in the next lesson, okay? Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.